All right, here are quiz 3 solutions. So let's see, in the first problem, we're given this function. It looks like it's in purple or whatever here, this function f. And then given 3 other functions, a, b, and c, and asked which of these 3 represent the derivative of this function f. The answer is c. C is the derivative. C is f prime, maybe. Maybe exclamation points a little over the top. C is f prime. How could you convince yourself of that? Well, there's a few ways. I think the easiest way, or at least the easiest way for me, is to look at a and b. The height of both a and b when x equals 0 is 0. Right? A and b both go through the origin here. Their height is 0 when x equals 0. So if either a or b was the derivative of f, then f would be flat, would be horizontal when x equals 0. It's not. F is decreasing when x equals 0. The slope of the tangent line to f when x equals 0 is some negative number, as c indicates. A and b do not. So c is f. One possible reason why is because a and b both have height of 0 at x equals 0, but f is not flat, horizontal, is not flat, whatever, you'll know what I mean, is not flat at x equals 0. Lots of other arguments. I mean, the basic idea with f is, let's see, it's decreasing, decreasing, decreasing all the way until you get somewhere in here where it looks like it's pretty flat, and then it's just barely increasing, it looks like, if you look at this purple line. Decreasing a lot, flat, barely increasing. If you look at c here, it's negative, 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 but less and less negative until we get here, where f is flat, and so c has a height of 0, and then it's just barely positive, because f is just barely increasing. So whatever, mention anything similar to that, and you're good. On the next one, label the 3 curves below as g, g prime, and g double prime. Add a sentence or two justifying your answer. Okay, well, let's see. Probably, what's the easiest way to go about this? Okay, one thing to notice is that C, this blue graph right here, is decreasing, right? Everywhere from this point right in here over to here, it's decreasing. C is decreasing. Note, C is decreasing from here to here. This is probably from here to the left, less arrows, to the right. So C is decreasing from this point everywhere to the right. So if C were the function, its derivative, C is decreasing from here to the right, so its derivative is negative. A and B are always positive. So what I'm saying is that A is not the derivative of C, and B is not the derivative of C. So A is not derivative of C, and B is not derivative of C. So C is G, we're not talking about F anymore, G double prime. Once you find one of them, the rest follow a little bit easier. So we got C is G double prime. So maybe I'll continue in a different color here. So C is the derivative of G prime. So we look at C here, and it's the derivative of either A or B. C is the derivative of G prime. C's height is close to 0 here is close to 0, yeah, okay, here. Right, the height of C is getting really, really close to 0 here, right when B gets close to flat. So C's height is close to 0 here, where B is almost flat. So what that tells us is that C is the derivative of B. C is the derivative of G prime, so B is G prime. And by process of elimination, A is G. You can check that. Here's my function right here, A. Let's see, it starts out almost horizontal, but then it starts going up, and it gets up quicker, 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 it looks like. So it's increasing the whole way. It starts out not increasing very much, but it increases faster and faster. So what I want is a function who starts out close to 0 as its height, and just gets higher and higher as we go to the right. It's exactly what B does. So B is the derivative of A, and then if you look at B, here's a function that looks like is going up pretty quickly right to the start. Hard to tell what it's doing right here, but it's increasing almost right off the bat. But then it starts increasing slower as we go to the right. So it's always increasing, it's always positive, but it's increasing slower and slower after we get past some point in here. It's exactly what C is doing. It starts increasing really quick, but then the rate at which it's increasing is getting closer and closer to 0. Anyways, A, B, C, there's the answers. Oh, these are a pain to describe. Sucks for the grader. Number 3. Suppose that the below curve is the... Hey, you've seen this before. This was the perfect problem curve. Suppose that the below curve is the derivative of a function h. In other words, h prime is shown below. Okay, so this is h prime. This is the derivative. Use that to determine the following. And then I'm here, careful, the graph below is not h, it's h prime. Just because I've given this problem in the past and people made that mistake. This is the derivative of some function h. Use the above graph to determine the x values on which h is increasing. H is increasing when h prime is positive. I guess I can write positive. Which happens at, let's see, when is this thing positive? Well, it looks like from somewhere around here to somewhere around here, and then from here to there. So I would say from at about, I don't know, negative 0.4 and all the way until we get to, what's that, about 0.5? And then again from what, 1.4, 1.3, something like that. Let's call it 1.4. H is increasing when h prime is positive, which happens at about that and this. Couple notes here. Brackets should be open. But no credit taken away if not. Or if instead of this being 1.5, if you made it infinity, that's fine too. If you kind of thought about this as an arrow at the end, that's fine. I don't really care. Anyways, you know what? I think that just makes it worse. I'm going to erase all that. Nope, I'm not. Points taken away if not. Let's leave it at that. Good enough. Use the above graph of h prime to determine the x values on which h of x is concave down. H of x is concave down if h prime of x is decreasing. Looks like I should probably switch colors, which happens at about, let's see, where's this decreasing? Well, it starts out decreasing until we get to here. So from -1 to this point, I don't know, -0.8. -1 to -0.8. Where else is this thing decreasing? Where else is this going down? Well, from here to about there. So what is that? 0.1 maybe? All the way up to, I guess, a little bit bigger than 1.1. If you put 1 there, that's fine. I don't care. So a function is concave down if its second derivative is negative. Its second derivative is negative if its first derivative is decreasing. Its first derivative, which is given to you right here, is decreasing over here and then again over there. Is h of 0.5 a local maximum, a local minimum, or neither? Local max happens when h prime switches from, let's see, if it's a maximum from positive to negative. So the idea there is if the derivative used to, if the function used to be going up and now it's going down, you're going to get a local maximum. In other words, if the derivative used to be positive and now it's going negative, you'll get a local maximum. A local min happens when h prime switches from negative to positive. Kind of same idea. If the derivative switches from negative to positive, the graph used to be decreasing, now it's increasing. We get a local minimum. So let's go up and look at 0.5 and figure out if the derivative is switching from positive to negative or negative to positive. Well, let's see, here's 0.5 right here. And it looks like the derivative is switching from positive to negative, right? At 0.5, to the left of 0.5, the derivative is positive. To the right of 0.5, the derivative is negative. So we are switching from positive to negative at x equals 0.5. H prime is switching from positive to negative, so it's a local max. Something like that. I mean, you don't have to write out all this stuff. That was just to try to help. I guess that's the end of the quiz.